Good day, good people. In today's lesson, introductory is cyclic quadrilaterals. But before we go there, let us just have a small revision of the three theorems we have learned so far. Saka tiri kuita circle geometry, and in circle geometry, we focus on theorems. Ma-theorems aya anotibatsira kuwanei. Ma-theorems aya ndeyekuti twane ma-angles anenge ari inside a circle. So ma-theorems atakaita so far, the first theorem, which I will call theorem number 1, I'm just going to paraphrase. In theorem number 1, takati angle at the center, kureva angle iri pakati, is twice the angle. We use the technical term subtended, very important term, at the circumference. So to just exemplify this, let us say this is the circle we have. We have a center, usually called O. Then we have a system of lines, yakadai so. This is telling us that if this angle is theta and that angle is alpha, theta uno yangari 2 times alpha. Saka theta is 2 times alpha. Tikada kuzvimathematize, what it means is alpha is going to be equal to 2 times, theta is going to be equal to 2 times alpha. Let me explain this in Shona. Kana tichida kuwana angle iri pakati, tino multiply angle times 2 inenge iri pa circumference. Kana tichida zvakare kuwana angle iri pa circumference alpha, it is going to be half of chi? Of theta. So this is the first theorem, which also happens to be one of the most important theorems you are going to apply. We can apply this also given a situation like this. Let us say this is our center and we have systems like this. This angle, let us call it beta maybe, and let us call this angle omega. Saka beta is equal to 2 times omega. Omega is equal to half of beta. That's important. You can watch our earlier videos to understand it better, because we did this through calculations and examples. Let us revise theorem number 2. For our second theorem, which is theorem number 2, what we learned is if we have angles in the same segment, they are going to be equal. So angles in the same segment are equal. An example here is we have a circle, then we have a system like this, our center like this. Angle ino-ish, let us call it A, and this angle B. Angle A is going to be equal to angle B because they are inside the same segment. So in the lesson we learned about this. I demonstrated on a board how best you can get it. If you didn't understand my demonstration, you can ask in the comments and we'll make another shorter video demonstrating it again. But these are angles inside the same segment, and this is actually a major segment. We can have angles inside the same segment as a segment yacho iri a minor segment like this. This angle C and D. So C will be equal to D. Very important also. We can have a center somewhere here. And it saka izvi zvakakosha. Mukacherechedza through many examples, you are going to see the system of lines inside a circle anotipa a go ahead yekushandisa theorem number 2 are going to be more like this scissors shape. Kashepi kakaita seka A mark kana kuti ka W regarding kuti makatarisa sei kacharamba kachita make an appearance. You can check here like panapa murukaona ka scissors shape kakaita seka M like panapa futi panapa pa number 7 panapa, and also on this example. So when you see ka shape kakaita seka M kana ka W dependent kana ka scissors, however you see it, you should quickly think of theorem number 2. The other thing I want to educate you on, akuna question inoya chifunza in particularity kuti theorem number 1 ichi, theorem number 2 ichi. These things are not cast on stone. So instead of kukrema kuti theorem number 1 inoti chakati, number 2 inoti chakati, you can just know ma theorems acho kuti anoti kudini. Because when you apply these theorems, you are going to apply them musina pasina question inoti tiudze kuti theorem number ani, because different books present these theorems differently. Zvasiyana nema Newton laws of motion or other lists which seem to be really specific. Ma theorems aya kuti theorem 1, theorem 2 is just for the sake of numbering them, but it's not something you have to worry yourself with. Just know kuti ano apply was say. So this was the second theorem we learned. Then in our most recent lesson, where we did a theorem number 3, which was saying angles in a semicircle are 90 degrees. And so the angle, actually it's an angle, it's singular. The angle in a semicircle is 90 degrees. An example would be this. Could if a semicircle, we should have a diameter which passes through the center, and I re-emphasize could pass through the center. Then we have a triangle which comes out of it. This angle is going to be 90. They can do what they did here. Kubatanidza zvinhu. Could we are having a triangle-ish, because this is a diameter passing through the center. Then we have this triangle. You should know kuti ino angle E ndo inenge iri 90. So if we come back here, it can be in any shape or form, so long it's a triangle formed inside a semicircle. This angle is going to be a right angle or 90 degrees. So this is just a summary, a rundown of the theorems we have learned. We are now going to look at cyclic quadrilaterals. Saka ma cyclic quadrilateral akakosha. I cannot begin to emphasize kukosha kwa akaita. So let us begin to break down this term so that we can understand what they are. What you should appreciate firstly is you have to be able to notice cyclic quadrilaterals. They are not always going to be obvious, but they are going to be obvious. You can have a quadrilateral inside a circle, but it's not a cyclic quadrilateral. So in a moment, I'm going to explain what a cyclic quadrilateral is. But take a look at this. We know that a quadrilateral is any shape with 4 sides. From the word quad. Kanamri boys, you can link this to a quad bike. Do you know a quad bike? Kabaskoro kanima firifo kake. And I am sorry, I don't know which example which is feminine. I can link the word quad, but it should be there somewhere. So quad just means 4. Lateral is talking about straight lines. So a quadrilateral is a shape with 4 sides. Think of a square, a rectangle, trapezium, kite, rhombus, parallelogram, and keep on counting. Then something which is cyclic, it loosely means inside a circle. But the catch here is If it is a cyclic quadrilateral, it should have all its 4 corners or vertices touching the circumference. Makona aya ari 4 ese ari 4 anofanirwa kunge ari pa circumference, ndiko kuti inzi a cyclic quadrilateral. Ikauya yakadai so, hama, this is the center. Ngatiti yoya yakadai so. Yodai. As you can see, so this is the center. As you can see, this shape has 4 sides. But it's not a cyclic quadrilateral because only 3 sides dzakabata circumference. All 4 sides, let me write it this because this is like the most important fact here. All 4 points, corners, let me call them corners for the ease, but to those who are more technical vertices, all 4 corners or vertices should be on the circumference. All 4 of them. That is the trick here. Then when you understand how to identify it, then you can go on to apply the theorem associated with it. If we look at our course reader, Cyclic Quadrilaterals, and we read this part, the vertices, so they are using the technical term kuti vertice zvinongoreva kuti corner, and so don't confuse yourself. The vertices of a cyclic quadrilateral lie on the circumference of a circle. Example panapa murikuona pana A, pana D, pana C ne pana B. Moona zvakare pana P, pana S, pana R ne pana Q. So before you can apply cyclic quadrilaterals, you should make sure, confirm kuti every corner, every vertex iri pa circumference. Then you can apply the following theorem. But the theorem we are looking at is this. Iri kuti opposite angles of a cyclic quadrilateral lie in opposite segments of a circle. Let us read the theorem again, which will make number 4. The opposite angles of a cyclic quadrilateral are supplementary. Saka the word supplementary, what it means is, it means add up to 180 degrees. Saka kana ma angles ari supplementary, zoroti tikama add anotipa 180 degrees. This has nothing to do with this lesson, but you should also know that if angles are complementary, it means they add up to 90 degrees. And so what are we talking about? We are saying opposite angles of a cyclic quadrilateral, and they lie in opposite segments of a circle. So if we look at this, the opposite angles of a cyclic quadrilateral are supplementary. My opposite sides actually happy. They should be the sides which lie in opposite segments. We defined a segment. Tichiti tinogadzira segment tichishandisa zvinhu zviviri. It's either the arc or the chord. So kana chishandisa chord, it will be something like this. This is a major segment. This is a minor segment. And it kana kuti we can just be using an arc. Arc, remember, it's just part of the circumference. Saka AB. Kumsoro kwa AB kunoku. Oku. Kumsoro kwa AB. Ndiko kunechi major segment. Then conversely, cannot vice versa, kuzasi kunoku kunechi minor segment. And it. Saka kana ma angles ari mu ma segments akasiyana, angles acho ndo anonzi opposite angles. Then kana tagona kuidentify opposite angles, we should know the theorem number 4 we are using, inoti the opposite angles of a cyclic quadrilateral are supplementary, or angles in opposite segments are supplementary. So this is the wording. We are not going to repeat it because we are more concentrated on application. If you want, you can follow through the proof. I'm not going to teach through the proof because it's immaterial to our syllabus. But if you are inquisitive and you enjoy mathematics, I would encourage you follow through the proof. If you want me to help you through the proof, you can communicate through comments and we can arrange a video explaining the proof step by step. But going back to our work, let us see if we have any questions to practice this with. Let us come here to example number 3. Saka inini I reproduce diagram iro to be able to illustrate kwamuri kuti zviri kufamba sei. When you are answering this in your ZIMSEC paper 1, paper 2, you don't have to repeat it because you can just use your pencil to scribble around. Saka I'm going to try to draw this shape as it is. Okay. Yeah, this is the shape. Then to join A na C. Panika E karipanapa. Then to join na E, then na D. Okay? Amenoti scissors yangu ya ubuda ere. Ndruto yona scissors ya buda. Amenoti mimi ruiona ere. Alright. Toudzwa kuti shi iri line iri, which is EC, cannot see iri kuita pass through the center. Then we are told this is 127 degrees. Question iri kuti CE is a diameter of circle ABCDE. If ABC is equal to 127 degrees, find ACE. So AC in the EU. Let me now give you the advice I used personally when I was answering questions to do with circle geometry. Pandaita mibvunzo ye-circle geometry, what I did was, because my theorems higher, it was not paper number 4. I think from NGM book 4 share with 3. Saka my theorems higher, let us just say they are around 7 or more. So akawanda, you see. And in order for me to avoid confusion and clutter, what I could do is, before I read the question, I would fill in all the angles I know. Nsanda verenga question. Because andisi kuda kuita blockade, kana kuti kuita tunnel, yavanoti tunnel vision mchirungu. Tunnel vision, kutadza kuona zvinhu, kana kutadza kuita think outside the box. Like we are focused on solving, in this case, ACE. So you fail to see how other angles connect to give you ACE. So this is something which really happens, because in most cases when you are doing this, you'll be given 4 or 5 angles to solve inside a circle. And what happens to most people is they'll be confused because they are focusing on the particular angles. So in order to avoid that, in ZIMSEC when I wrote, before I looked at the questions, I looked at the diagram and fill in as quick as possible all the angles I could fill in. Then ndosenda ku question. Ndonotarisa kuti angle yandafila in pane here ine answer. Most cases ndaiwana kana 3 angles. Dzitori part of zvandatoita fill in sandatarisa question, then ndongonyora. Dzimwe nguva every question inge yakadaro. Saka I'm giving you this as an advice. This is what we are going to be doing from now on. You can come across an angle you cannot automatically fill in. Don't worry. Fill in zamnokwanisa and motarisa question, more not ma answer question ere kana musina, then mozo ta think through again. Saka let us ignore question irutu kudini. Ngati ngoisai ma angles atinosiva. Chekutanga tarisisai. Mukatarisa A, B, C, D. Can you see kuti B ari pa circumference, A ari pa circumference, D ari pa circumference, na C ari pa circumference. Then tikatevera A, B, C, D tinoona kuti is shape. Because of that, tine cyclic quadrilateral. But because tine cyclic quadrilateral, theorem inoti kudini, inoti opposite sides add up to 180. Saka since opposite sides add up to 180, what it means is, ndinowanzo kufarira, but let us just do it like this. Saka zoreva kuti angle ABC and it ABC plus angle ADC should be equal to 180. Then I encourage you kuti kana madaiso munongonyora a very short statement inotsanangura kuti mazvanepi mongoti opposite sides kana kuti opposite angles in cyclic quadrilateral. And it saka tiri kutsvaga ADC, so ADC is equal to 180 degrees minus ABC, which means ADC is equal to 180 degrees minus what is ABC, 127 degrees. Saka ADC is equal to 53 degrees from 180 minus 127. Korot panapa total yato isa 53 degrees yedu. Mapaona. But chiri 53 degrees chi. And it 53 degrees I angle inenge iri opposite but iri mukati me cyclic quadrilateral. Saka cyclic quadrilateral yedu zoreva kuti I angle ish ndiyo inenge iri 53 angle E. Pane ka piece kanaka kari kusara. Ka piece kari kusara ndi EDA. Let me pause a little for you to ponder. I really want you to see panapa. Ka piece kari kusara ko kaoneke. Because 53 it's part of a cyclic quadrilateral. Kureva kuti kunyangwe pana D panapa ndiri. This angle D. Hatisi kuda EDC. Tiri kuda ADC. Koroti tiri kutotsaura part ya E. So ka angle ka EDA tinokawana say. Let us look again panapa. Can you see kuti we have a sender O? Kunyangwe yayo isina kunzi O, but ka line akakari represent sender. And having a sender, can you see that we have a triangle? Let me show you here. A triangle which is being formed by a diameter, which means pesapa is going to be 90 degrees. What do I mean? Zvinoreva kuti angle ADC is equal to 90 degrees. Angle yes, it's 90 degrees. And the reason is angle in semicircle. Zvacho zvinobatana ende zvinonakidza kana makuzvinzwisisa. Saka taona kuti it's angle in semicircle. Then what is going to happen next? Ngatitarisei futi panapa. Okay. Saka EDC is equal to 90 degrees. But tikacherechedza tichaona kuti EDC is equal zvakare to EDA plus ADC. And panapa ansikuda kuti murasike. Let us come here. Saka alright, ngatuitire panapa. Taona kuti tineka angle kanaka kadika kasira counted off. Then calculate tichishandisa opposites of a cyclic quad which are equal to 180. Tikaona this is 53. Saka tika edda ka angle kadiki plus 53 itofunga kuwana 90. Andite. Saka tawana 90 zoreva kuti panapa trikuda ka angle aka ka EDA. Saka tenge tangoita make EDA subject to formula. Saka EDC to subtract ADC tinowana chi EDA. Saka EDC is 90 minus ADC, which is 53 degrees, tinowana chi 37 degrees. kureva kuti kaengo kanaka i37 degrees. But scissors yangu amenoti yanga yaonekwa here. I'm sorry, I should write final answer panapa. Handizi kuti scissors yangu maiona here kuti engo ino ishi inenge iri equal to angle E because zviri kugadzirwa ne the same chord or zviri in the same segment. Saka tiri kuti ACE iri equal to we can call this ADE. And what is the reason? Angles in same segment. Then mukatarisa reason yapiwa nebhuku redu vati angle vati in same segment as EDA, but you can just say angles in same segment. Kureva kuti kana kaengo aka kari 37 zorati apa futi 37. Saka engo yatiri kutsvaga ACE is equal to 37 degrees. Saka handizive kuti zvabuda here zviri apparent, because this is very important stuff. Tabva kupi ta-apply 3 theorems. The first one yatabva kudzidza inoti opposite angles inside a cyclic quadrilateral, if you add them they give you 180. Tika-apply angle inside the semicircle, tikazopedzisira neku-apply angles inside the same segment. So this is special. You are going to apply many things. So I think advice yandapa yekuti just start by working with the angles you know. It's going to help. Okay. So tapedza ne ino. Let us go to this example 4a. Saka example 4a tinoita say, maybe let me just write it here. It's a question. In Fig 14.22, PQRS are points on a circle, center O. QP is produced to X. If XPS is equal to 77 degrees and PSO is equal to 68 degrees, find PQO. So let me try to reproduce the diagram. Saka we have a line QPX and it QPX. Then tova pa Q tienda pa O, tova pa O tienda pa S, chava pa S tobatanza P na S, so it's something like this. Okay, then tozoda iso R arobatana na S like this. Saka that angle tells out this angle is 68 degrees, tells out this is 77 degrees. Okay, so that is what we have. Chekutanga, what I want you to appreciate panapa, we have a cyclic quad, and maybe if you actually write a cyclic quadrilateral, the moment you see it, you write it down, which is QPSR. QPSR. Why is it cyclic? Because all the four corners are kubata the circumference. That's why it's cyclic. Okay? And because it's cyclic, kana kunogu kunze ari 77, mukatuma ngari chi. So tuda kutsvaga angle QPS, but toziva kuti QPS plus 77 degrees should give us 180 degrees. Why is it that? Because these are angles on a straight line, and we know that angles on a straight line are equal to 180 degrees. Saka kuti tiwane zvatiri kutsvaga apo, QPS inenge yangova equal to 180 degrees minus 77 degrees. So what do we get when we do that computation, kana kuti calculation? 180 subtracting 77, it's 103. So 103 degrees. Kureva kuti panapa it's 103 degrees. But angles in opposite angles in different segments of a cyclic quadrilateral give us 180. Kureva kuti angle ino ish ne E zofunga kuti pa 180. Saka if we are just to add them, QPS plus QRS should give us 180 degrees and angles in cyclic quad. In cyclic quadrilateral. Yeah, you write it like that. What does it mean? What is Truda QRS? So QRS, we make it subject to formula, will be equal to 180 degrees subtracting QPS. And what is QPS? QPS is 103, remember? Saka panapa it's 180 degrees minus 103 degrees. Tinowana. So when we do the calculation, tinowana 77, but let us just do it because it's just a reverse of zvatabva kuita. So 77 degrees. So this is 77 degrees. You might be tempted to, since panapa pari 77, saka ino it should be 77. We are going to do something which is like this, but when we are now doing book 4 stuff. So equals to the longer way of doing what I'm doing. So that's 77. But angle ito kwanza kuiwana kai tichishandisa the first theorem. Not angle at the center is twice angle subtended on the circumference. Saka zoreva kuti QOS inge equal to chi 70 QOS inge equal to, let me just write it in terms of angles, QRS times 2. And what is the reason? Angle at center, and it is equals to panapa angle at center is equals to 2 times angle at circumference, but I can just say angle at center. Saka what is QRS? That's 77. So this is equal to 77 times 2. What is 77 degrees times 2? 154 degrees. Kureva kuti panapa it's 154 degrees. But taona kuti apo it's 154 degrees. We can find this angle. It's easy. Teta ngoti 360 degrees minus 154 degrees. But angle yatiri kutsvaga takutongokwanisa kuiwana. Saka let us ngatingosiya that step. Let us go straight to angle yatiri kutsvaga. Angle yatiri kutsvaga, it's from the question PQO. Saka chekutanga tisati tatomboenda ikoko chatanga tatsvaga sum of angles. Izvi mofanira muchitongozviziva of quadrilateral. Sum of angles of any shape is equal to n minus 2 times 180. N yakamirira the number of sides. Saka n is equals to 4 for a quadrilateral. That is tichati 4 minus 2 times 180, which is 2 times 180, which is 360 degrees. Waitadaro. Kunyangwe isiri a cyclic quadrilateral. This is not a cyclic quadrilateral, and I might ask you the reason why. It has 4 shapes. Nemakai isiri cyclic quadrilateral, or are we practicing favorism? No. Because only 3 vertices or 3 corners are touching the circumference. Imwe corner yakabata pa center. Saka it's not a cyclic quadrilateral, but it remains a quadrilateral with 4 sides. Saka since tawana this angle, tukawana that angle, tinokwanisa kuwana angle E through basic adding. Saka tinenge takuti since tawana kuti this is 360 degrees, tinenge takungoti QOS plus OSP plus SPQ plus so this should be 4 angles. Saka QOS, alright, plus its PQO should give us 360 degrees. Saka mukagona kuziya kuti how do you denote ma-angles aya, it helps you. That's why I'm doing it. Otherwise we could have just said Q tovataisaka cape pamsoro zvongora kuti angle at Q, but I'm doing this because this is the language of circle geometry. So tiri kudei panapa tiri kutsvaga PQO. So let us make PQO the subject of formula. So PQO inge equal to 360 degrees minus QOS minus everything becomes minus because zviri kujamba chi equals sign, don't forget that, like this. Saka PQO equal to 360 degrees minus what is QOS. Saka QOS ndio yatacalculate tikawana chi QOS tawana 154 degrees. So 154 degrees subtract what is OSP takaipiwa mquestion 68 degrees subtract what is SPQ, we calculated it panapa tikaona it's 103 degrees. So let me just put this inside our calculator tuone kuti what do we get. So 360 subtracting what? Subtracting 154, subtracting 68, subtracting 103, we get 35. And as you can see, this 35 is the same as the answer they are getting inside the book. So if you follow my method and follow the method of the book, they are different a little, because panapa vapa this reason vangoti QRS is going to be equal to 77 because it's an external angle of a cyclic quadrilateral. Hatisati taita that theorem inotudza kuti external angle of a cyclic quadrilateral is equal to an internal angle. Saka we stick with what we have learned so far. Tinotanga tatsvaga this angle, tozoshandisa angle E ne ish, toshandisa angle E kuwana angle ish. So these are the steps samadzangu. If you have any questions, don't hesitate. I think I wasn't fast. I think I was explaining every step as it came. So that is it. Now, let us go to our exercise to just discuss. Saka ndine ma questions andicha electa kungokupai as homework. Ndine ma questions andichaona necessity of helping you. Because my questions are taura because angari are relatively easy. Saka, this is your number 1, exercise 14C. Irikuti, this is homework. You can do this. Because iriku tester if you understand the language of psychogeometry. So I'm not going to go with you through it. If you attempt it and maybe you contact me via comments or on my numbers with a genuine concern. If you bring a question from any of our lessons to my numbers, maybe you work and you bring a question, you should also bring the way you attempted it. Like, to get an example and you don't understand it, also send me like proof of when you attempted it, so that I can pinpoint where exactly you went wrong. You understand? So that's your homework. Number 2, irurati find the marked angle in each of the following, where we have a point O as center given. It is given. It is the center of the circle. Then the end is make a careful copy of each figure and write in the angles as they are found. And it. Okay. So let us discuss here. So what we want to discuss, Panaba, is whether you can see what I'm trying to make you see. So we need this angle. Angle ish, the 40. reason ndeyekuti kudini angles inside the same segment. Ka M kangu kabuda kana kuti ka scissors kana kuti ka W, regardless how do you see it. So kana tine ma angles 2 inside a circle, echi3 achanetsi kuwana. So that's it. B inoi E 90. White sheet 90. Reason muri kuona kuti pama reasons angu handisi kupa kuti theorem number hani because it's moot. Ma reasons angu ndinongopa a statement. Reason ndeyekuti that's an angle inside a semicircle. Saka tava ne 2 angles ne missing angle inside a triangle. Izo ndakukusira yo, otherwise you can look for a grade 7 to help you. I'm just kidding. Then panapa, what is going to be per C, just discussing. Saka C, as you can see, here it's one per C. And it because angles on a straight line. Take one angle ish. Then can you see guti e angle in its one? Opposite sides of a cyclic quad. That's cyclic because makona isari for akabata circumference. Saka na angle isinganitsi kwana tiashandisa angles on a straight line kwana ish. Tane 2 angles echi3 nitsi kwana. Then codit na ita say we are just discussing panapa panetsi kwana apa. Kwana the opposite side of O kungoti 360 minus 116. And it oro ya tawana ipapo then apa panetsi kwana apa because half ye E ndio yepanapa. Saka tavanichi tavane 1 2 3 angles inside a shape with 4. That's more like a kite inside a shape with 4 sides. Saka tine 3 angles mukati me shape ine 4 zoreva kuti ainetsi kwana. But let me help you part D because most people make mistakes up. Okay. Indo yatiri kutsvaga. Mistake noita vazhinji kufunga kuti angle yatiri kutsvaga is going to be 25. No. That's hapazipo panoshanda angles inside the same segment. Angles inside the same segment should be coming from not from a common point because panapa ari kubva from a common point. Angles inside the same segment, they come from a common arc or a common chord like this. And it ari kubva pa common chord ka chord kacho aka kana kuti common arc haasi kubva pa common point. Saka kana M asingabudi azvishande. Tichaiwana sei ainetse. Why? Because angle ish handika ainetsi kuwana angle ino E tinoiwana sei it's just going to be 116 dividing 2, which is 2 into 2 1, 2 into 11 that's 5, get 1 into 16 8, so that's 58 degrees. Why tiri kuti ndi 58 degrees? Why taita zvataita? Reason iripo ndeye kungoti angle at center. So angle at center is equal to 2 times angle at circumference. And it at circumference like this. The angle iri pa center iri times 2 angle iri pa circumference. Kureva kuti kana tichida angle iri pa circumference tinongo divide na 2. You understand? Then kuti tiwane this angle ainetse, it's just going to be 360 degrees minus 116 degrees. And what is the reason? Reflex angle at center. So the reflex angle at center like that. Okay. Saka 360 subtracting 116, that's 244. angle iyi kuti tiwane tinenge takungoti 360 degrees. 360 dziri kubva pakuti ndiyo the sum of angles inside a quadrilateral. This is a quadrilateral, believe it or not, because we have this side 1 2 3 4 sides, but it's not a cyclic quadrilateral because 3 ma side kana kuti 3 ma angle 3 ma corner ndo akabata circumference. So it's 360 subtracting 25 plus 58 plus 244. Saka tango edda ma angles ari mukati to subtracta zvatawana the sum from 360. So what are we going to get? 360 subtracting 25 plus 58 plus 244. It's 33. Saka panapa it's 33 degrees. As you can see, it's very different from 25. Saka most people make this common mistake. That is the reason why ndaona it's important we do it together. Then it's quite easy. Why do I say it's quite easy? Okay, saka we can get this angle, and we can actually get this angle yesay tichishandisa chi angles on a straight line tokwanisa futi kuwana angle yesay. Okay, but this is a cyclic quadrilateral, remember. Saka because it's a cyclic quadrilateral, opposites should be complementary. It's a cyclic because all the four corners akabata circumference. Tinogona kushandisa angle ino iyi kuwana ka angle kadikaka, but kana tawana ka angle kadikaka takuchishandisa that V shape kuwana this angle foot. Then kana tawana angle E tinenge takuita sei. Let me give you this as a homework. Mukaitadza munouya nayo. It's intricate. It's intricate. You are going to apply many things and you are going to find many angles. But I think it's doable. That's why I'm giving you. Okay. Then this one is too simple because 360 minus 126 to an E, half a E in the ish. So I can do this one. Then panapa inenge isina kana angle mukati kana chi inenge yakangoratidza a system of parallel lines. It's not even a cyclic quad. This one, do a research. So you can use different tools. You can use artificial intelligence, ChatGPT, etc. to do a research, say. But that's not usually examinable. So for that one, do a research. Then for that one, I'm just going to help you to show you this is 90. Triangle made by diameter, angle inside a semicircle. And you can, of course, use that to find this. And you should also see kuti katwenda kakaenzana neka angle kanaka because of angles inside the same segment. Saka kana tatozwana zvakaita seizvo azvichatinetse. This is also beautiful. Do as homework. Then panapa, this is a cyclic quad. Kureva kuti you can find this, then you can work around it. Saka angles inside a semicircle anongo apply kana iri triangle iri kugadzirwa mukati mesemicircle. Kana iri imwe shape doesn't apply. I think I didn't clarify on that. That's very important. Okay. I also want you to do a research here. Yes, we also do research here. We are learning. We are not here to cram and just get into an exam and pass. We want to build thinking skills for the next generation. We don't want people who are credentialized, like people with certificates, but they don't know how to think. We want people who can think mathematically so that we can solve the problems in our African societies. So we are also going to give you research. Go and do a research on a question to see how a problem is solved. Number 3, in figure 14.25 AB is a diameter of a semicircle, danke, and blah blah blah. Calculate BCD. Aya questions anoda kuti muite mujoine like parikunzi join int, join CA. They are not examinable, but so we will leave them for research. Then panapa you should know kuti you are going to apply angles inside opposites of a cyclic. Then kana mawana angle iya chanitsikwana angle ne straight line saka iyo chanitsikwana. Then lastly, let us see. Then these questions are points in circle. I think we answered that. And what about Panapa? Panapa, you can look at this and make deductions. Is this a cyclic? Yes, it's a cyclic quad because S, P, Q, then correct Panapa I engo inetsikwana. Saka ikanetsinga netsikwana so that iya inetse. Alright. Yo. E question I think I should help you. It's a special question. It's special. Let us do it together. Seko saka P arunobatana na Q, then Q arunobatana na R ari kukondinya akananga kuna T, but P arunobatana na S ari samwe panapa, S wacho achibatana futi nani na R. So toda tsvaka this angle tapiwa kuti this is 20. Now taona kuti it's a cyclic quad because of P, saka we can write cyclic quadrilateral because of what? P, Q, R, S. And it saka kana taudzwa kuti angle iyi it's 80, zvoreva kuti this one is going to be 100. Andika? Because they are supplementary, saka it's just 180 minus 80 to get 100. But tawana this 100, can you see kuti angle iyi ino aichanitsikwana iyi andasheda iyi ka angle kanaka akachanitsikwana. Tinokawana sei ka angle ikakaka? Tinenge takungoti 180 subtracting 100 plus 20 because it triangle. Saka you should have an eye to notice my triangle anenge ari mucartoon. So this is basically 180 minus 120, 2, 3, 4, 5, 6, 7, 8, which is equal to 60 degrees. Saka is 60 degrees. But angle is chava futi 60 degrees. Why? Because of angles at an intersection. Tina nonzima angles at an intersection akadai so. Angle ino E. Mogona umatima X angles to remember. Angle E ingeri equal to angle ino ish. Angle E is equal to angle ish. Like that. And saka kana E iri 60 E. Zoro kuti E futi 60. You get it? But kana chiza kuti E is 60, E is 60, aya tu hafangu kutinitsa kuwana. Because tinongoti 360 subtracting 60 plus 60. Kuitira tizive kuti ine E dzatisingasitsi dziri equal to chi. So this is 360 subtracting 120. So what is 360 subtracting 120? Let us do it on our calculator. We get 240. So this is equal to 240. But tawana 240, we are just going to take 240 to divide na 2. Kuti tiwane 22, 20, 120. So this is going to be 120, 120. The reason being because my opposite sides pama-angles at an intersection kana kuti ma-angles ari pamaline ari kugadzira x ari equal zvoreva kuti kana tikabvisa 60 uyu na 60 from 360 which is a complete revolution tichasara na 240 but 240 wacho anofanirwa kusharewa equally between two angles. That's why I divide na 2 saka zvazvinongoreva ndezvekuti angle yatiri kutsvaga it's 120. It's a special question and I give you full proof and full permission to verify these answers, but it makes mathematical sense to me. So that's a special question there. Okay, any questions, don't hesitate. I actually enjoy questions because it means you are engaging and because ndinogadzira mavideo akakura vanhu vazhinji havafariri zvinhu zvakareba stereki uye data rodhura. So if you ask a question, it knows, yeah, it means to me you are engaging and it's an honor. Actually, it's an honor. So you can do number 6, 7. In fig 14.29, O is the center of the circle. And it zova zvanzi iyo e50, iyo e15. Calculate MOL. Saka MOL the angle iyo ndo iri kutsvagwa. Saka tinoicalculate say that angle. To calculate say, I want you to do a research on this question also. It's doable. Actually, I can give you a hint. This angle should be equal to that angle, but tisingadariki this angle and that angle, angles in the same segment. That's a hint there. Then number 8 is story na seko yacho. If you are interested, you can do a research here. Saka it's not a research. Let us call it a homework because question inogona kuuya. Andri kuita ma research, ma questions asiri as much examinable. Do andri kuita ma research, but this is important also. Nogona kuuya. Saka you research that one, you research this one, and you research this. Asikana musina time, you can go with that item. There are enough practice for you. So in fig 14 point tapa number 9, 3.1, calculate the value of x giving a reason for each step in your answer. Saka angle inowanikai. That's 180 minus 60. Disoga? Saka kana tawana that angle, what it simply means is inowanikai. Because this is a cyclic quad A, D, C na B. So yese zurikuwanikwa pa circumference. Saka kana iyo ichiwanikwa inowanikwa, ikawanikwa ichawanikwa. Maybe let us do test number 9. But before we go there, number 10 is purely research. Hakuna ma questions anoya achifunza kuprove any theorem. So it's purely research. Purely, I mean. So let us do that question together, which is our last question. But as I'm drawing it, I want you to know that my questions are, I also want from you, I want feedback from you if discussing questions is helping you. Because at this week, I'm just giving you hints and going. I think this is the best way of teaching this topic. So I want feedback if it's working. Then secondly, each question yataita, it's not enough kungoiona ndichiita inini kana ndichidiscussa. You have to try it on your own. That's the only way you can know kuti mashbata. If you don't try it on your own, you never know kana mashbata. So let us do this question together. So chirikuitika panapa, this angle. And what is that angle? Of course, we know kuti iyi ndi 60, but atisati tazviita, so let us not do that. Saka angle iyi inge iri equal to chi 180 degrees minus 60 degrees kuti tiwane chi 120 degrees. So this is 120. But so this is B. Andika taona kuti ino inge iri chi ABC. is equal to 120 degrees. Then we also know that ADC plus ABC inenge equal to 180 degrees. And why is this? Opposite angles in cyclic quad kana ngoti angles in cyclic quad. So cyclic quad ndichangoyi shortena, but in your examination write it in full. So what it means is ADC is literally equal to 180 degrees minus ABC, which is 120, ichatidzosera pachi pa 60, like we had said. But zvadaro, what is going to be this angle? Angle E ingeri equal to 180 minus 2x. The reason being, tikati 2x plus angle ish should give us, tikati 2x plus angle yatizivi ngatingoti C should be equal to 180 degrees. Reason yakafanana na E, opposite angles in cyclic quad. Saka C ingeri equal to 180 degrees minus 2x. You get it? Saka iyo angle yo shairi 180 degrees minus 2x, ko angle yi ingeri chi. Angle E, because these are now angles on a straight line, ingeri 180 subtracting angle E. Saka tichai some bracket 180 minus 2x. I know ndarasawana. What's happening here is this is because of angles on a straight line. Tawana angle E is an expression 180 minus 2x. Saka ndrukuto discover kuti kucalculate this angle and that one was not necessarily necessary, but it's important. Tawana this angle is an expression. Truda kuwana angle iri panapa, it's going to be 180 because it's a straight line, subtracting in brackets angle yacho tawana is an expression. Saka this is going to be 180, then minus times 180, it's minus 180, then minus times minus in over plus 2x. 180 minus 180 and then this 0. Saka angle in get it 2x. This is beautiful. Saka swataona not angle yon di 2x. Tinegeta I triangle kai. Angle in di 2x zvanga chigona kungooneka futi nekushandisa chi exterior angle of a cyclic quad, because hapa ndi 2x hapa ndi 2x, but tazviprova manje. Saka zvinotipa manyemwe tasiyana ne hatina kukrema, tazviprova, you see. Saka hapo ndi 2x kungoreva kuti this is 60 plus 2x plus x inofanga kutipa 180. Saka 60 plus 3x inofanga kutipa 180. Then 3x is equal to 180 minus 60. 3x is equal to, what is 180 minus 60? What do we get? It's 120. Tika divide na 3 kwese x inge equal to 40 degrees. So a quick mathematician could have just seen could happen to 2x before going anywhere. But some of us who are interested in formula, in steps, in constructing, not engineering an answer, we do not get a tenderera, but we come back to the same conclusion. So when questions become harder, those people who think through stages are most likely to get them correctly because they have taught themselves to break down a question. So this is today's lesson. As you can see, tapedza book 3 cyclic, book 3 circle geometry. Saka tichaenda ku book 4 circle geometry, where we have, I think, 3 theorems which are a little technical, but we will break them down. And with that, this cluster is done and dusted. If you have watched to this end, munondipisa manyemwe, and this is what I say. So if this helped you, please don't forget to subscribe, to like, to share to your friends and family and enemies if you have any. and also to comment. Comments are very important. Thank you to those who are engaging with us. If you have any questions, you can get to me on my numbers, which are going to be on the screen in a moment, or you can just write in the comments section whatever question you hold or question you have. If you need extra lessons, you can also contact us and we'll see how we can help each other. Thank you.